And the ball's height in feet is modeled by this function in the blue, where t is the time in seconds after the ball has been shot. What is the maximum height of the ball, and when does it reach its maximum height? This is from page 346 in an Algebra 2 textbook. So this is the function we're working with. It's a quadratic function. This is your c, which is also your y-intercept, which is your initial height where the ball from the ground. And then you have your b and your a of your quadratic function in standard form. So I've set up a xy plane. This represents the time, which originally is your x-axis, and then this represents your height, which is originally your y-axis. So imagine this graph is a parabola that opens down, and then we have this part that's not part of it. This is your y-intercept, and the y-intercept is positive 6. So over 0, up 6. Then this basketball is thrown up in the air, and then it comes back down. Our question is, what is the maximum here, which is our vertex? What's the time? So that's your time. And then what is your height? Those are your two unknown pieces. So I'm just going to scroll down here. When does it reach its maximum height? And when does it reach, what is the maximum height? So we want to know the time. So we have an equation that we used in a quadratic function. It's opposite of b over 2a. So if we go back up to our a and b, here is our b, here is our a. So opposite of b over 2a. Oh, this should be a positive here. And then we simplify that. Negative 24 over negative 32. And then we simplify that fraction. Negative negative is a positive, and then 0.57 seconds. So almost a second is our time. That'll be its maximum height. That's your x of your vertex. And now we want to find the y, which is the height. If you remember from earlier in this class, to find the maximum height, which is your y of your vertex, you evaluate this function for x. So here's your x term, and you say y equals, and you're going to plug it into that function's equation. Your equation is negative 16t squared plus 24t plus 6. We're going to substitute in 0.75 here and 0.75 there. Now we do our PEMDAS, we do our exponents first. 0.75 times 0.75 is 0.5625. Leave everything else alone. Then we'll take care of our multiplication next. So negative 16 times 0.5625 is negative 9. And then 24 times 0.75 is plus 18, and then we have plus 6. So negative 9 plus 18 plus 6 is 15. That's your y value of your vertex. As part of the problem, if we go back up to our picture, this question mark now is answered as 15. That's your maximum height of 15. So the ball is thrown up in the air at almost a second, and then it comes back down and touches the ground. So the second part of the question answered is 15 feet will be the maximum height of this ball?